a bit in your pocket or somewhere.
Be in the pocket?
Yeah, or in the back where you want.
Okay.
And then a bit below your beard. Because my is like
Okay. So otherwise, I'm gonna have it.
What time is it?
I think it's time.
On yours. You want, I can keep track the time for you. I give you the last 5 minutes of your 20 minutes of presentation.
I have 20 minutes.
Yes.
Okay.
I give you the last. I give you back for the last slide. And
Okay.
for the question, you repeat the question.
Okay. Thank you. Okay. Right. Thanks everybody. My name is Thiago Santos. I work for a company called Mapbox. Quick introduction. We make maps and we love open source. Yeah, the name tells it, right? We love open source. We are very excited to be here. And we maintain several popular open source projects like Leaflet, open source routing machine. And we also big contributors to OpenStreetMaps. Yeah, we work with tools like ID, and we contribute with data fixing data on OpenStreetMaps and developing tools to make improve the quality of the map. But today I'm going to talk about this particular tool. Is we call it Mapbox GL Native. It's not exactly a product we offer. It's actually the base for our products. Like we have a map rendering engine, SDK for Android, iOS, and is based on this. What I would say is a vector map rendering engine, which is open source, and I think it's really cool, bleeding edge technology compared to raster tile rendering engines. I realized when I was making this talk, we don't have a cool logo for this. Many open source softwares they have, and it was Friday night. Our designers, they were sleeping, so I made one. I think they're going to come up with something better Monday. Okay, but what's vector tile? So I was very fortunate because the last talk was awesome, and I was talking about a problem we have with maps. It's huge volume of data, and the satellites they keep increasing in resolution. I have heard that the Army in the US, they have satellites that take resolutions they can see if you have hair or not. So you want to display this huge amount of data in a computer that is somehow limited by several factors, including memory. So you have to tile the map, right? Even if you take OpenStreetMap, the sheer amount of data there is like several gigabytes, and you cannot display everything at once and just zoom in your neighborhood or in your door and expect that to work. So even vector data, you have to tile. So, so one strategy we see often, like when you're using Leaflet, for instance, like you take a big image and you tile, and as you go in, like as you zoom in, you stretch the image. So for a moment, like between the zoom levels, you have an image that doesn't look that great, and then boom, it gets replaced to a new image, and so on. So the nice thing about vector tiles, like they are, if you do the same thing with vector, it works exactly like a SVG. So you can stretch that because it's pretty much saying, I have a line from this coordinate to this coordinate. So when you zoom in, you just stretch that. Obviously, what defines the resolution is the amount of points you have in between this line. Like if it's a curve, we don't really draw, we don't say like you have a curve like this. We have several points in between that makes a curve. So when you are zooming in, you're going to see it turn into something a little bit squarey. But then it still looks much better than a raster image. So the vector tiles we are rendering here, it's based on an open standard. Okay, so it's not. We developed this standard, but we keep it open, so other vendors they can implement that. In fact, there are competitors, other open source projects using our vector tile specification. So this technology for rendering these vector tiles, like so you can have your beautiful maps in your application, is not really let's say vendor locked, in a way that we are making this open source project so you can use our services. So in fact, you can create vector tiles from your own data if you want to. And we also provide open source tools for creating these vector tiles. So for instance, like we have this typical, I still have to learn how to pronounce this. It converts GeoJSON to vector tiles. GeoJSON is fairly established format. So I think one cool application for this, I saw, like we have an app for the lectures here, and it has a map. So I've seen people using these vector tiles for creating indoor maps like this. We could have like just make a map of the university using, I don't know, GeoJSON, convert this to vector tiles, and render in the app, like with completely offline data. Yeah, I think that's pretty cool. Like it's, I'm not sure if when we designed this we had this use case in mind, but there's some people doing it, and I find it really nice. So I think the advantages of rendering your map in the client side are this: like you can do 3D effects, you can tilt the map. We don't do this in our engine today, but we are bringing this to our engine, like this native engine. Like you could do 3D extrusions, so you can see buildings in your city. The nice thing is, when you have a raster image, like imagine like a picture of myself, if I rotate it, what's written here in my t-shirt is going to look upside down, of course. But if you have a vector tile and you're rendering a map on the fly, client side, you have different layers. You know what's a road, what's a building, and what's a label. So knowing that your map is rotated, you may keep the label upright. It's up to you, because we also support styling. So styling meaning you can change colors of your map, whatever color. You can hide and show features depending on zoom level. You can change that on the fly. Like if you have a map in an app and you detect that the lightning is weak, you can make your map less brighter, so it's less aggressive, like if you're looking at night. And also, it's more compact compared to PNGs. It's often more compact. That kind of depends. Depends on the area you're looking, but most of the cases you're going to get better tile size compared to raster tiles. And as I mentioned before, you also have smooth zooming. You don't lose too much resolution when you're zooming into closer to the place you're looking. So this is one example. This is the map of the university. It's tilted and it's using one style, but just changing one flag or one property of the map, the style, boom, you have something completely different without downloading a whole set of raster tiles. Like It's all done in client side. So this is one. If it would be a raster tile, we would have to re-download everything. The other thing I find very, very cool about using vector tiles is you can query features, actually. So if you click here, you can say, give me what is in this area. So the map could give you back, like, you have a road, you have a building here, and the name of the building, you have the label here, right? So you don't need to go to a server and say, hey, give me what is at the coordinate X and Y. You can do it completely locally also. All right, so, and about the style, it's also open, it's standard. So specification is open, it's open for suggestions, and again, it's not implemented just by us. So back to the engine, we've been doing the development of this engine in the open source. It's on GitHub. So we brought this engine to different platforms, like including Linux, Mac, iOS, Android, and most recently we contribute this engine to the Qt project, which is, like, who doesn't know, it's an established C++ open source framework. So was very interesting to work with the Qt company. We're still working with them, and so you can use what they call QML. It's a language for describing user interfaces. It's very easy. It's way better compared to something like HTML. I think it's the last time I do a talk using a HTML slideshow. It's horrible to make this. Really, like, put this image aligned in the center here. It took me 30 minutes. Anyway, so we have our engine on Qt now. It's going to be there by default from Qt 5.9, which is the upcoming release for this year. And you could do in the future something like just like this, like window. You change the string to Mapbox GL here, put some coordinates. If you're familiar with QML, this code, it's a bit simplified here, but with 6 more lines of code, this is enough to have a window with a map centered at a coordinate. This is in Oslo at zoom level 10. So QML is pretty cool. It's very easy to read. And yeah, and you can get with Qt, you can get the same map on your phone, on desktop. And we're trying to get this running on Windows today because we don't support Windows at the moment. But with Qt, we saw maybe a window, no pun intended, for that. So what about a new platform? Because the idea, one of the ideas here of this talk is like to invite developers to get vector maps, better maps in other platforms. Like I know that GNOME is using our raster tiles. I would love to see, I don't know, GNOME maps maybe using vector tiles. I don't see why not. We brought this to Qt, so competition is on. So what do you need for having this engine running in your whatever framework you have? Could be, let's say I'm using GTK here as an example, but you need a decent C++ 14 compiler. We use some features, and it's not every compiler that can do it. For instance, Clang, recent versions of Clang can do it fine, but GCC, you need GCC 5.0. We had some issues with customers using GCC 4.9 and complaining about, GCC 5.0 is too new, even though I think it's 3 years old. So we are bringing it back to GCC 4.9. Maybe Debian is still using 4.9, I don't know. Apart from that, you need OpenGL. we rely on OpenGL. It could be OpenGL ES if your platform supports that. And you need to do a little bit of plumbing because the engine is designed in a way that you have the core of the engine, and you have the platform bindings, so you can plug your platform. For example, we did some experiments, and we got this running on the Unity 3D SDK by just replacing this part. So you need some main loop, like if you're porting this to GTK, I think glib gives you that. You need some thread IPC. Again, like glib gives you that. I know there is this G async message or something like that. And you need a network stack. It sounds big, but we have in our engine some implementations of portable network stacks. For instance, we have already Lipcurl implemented. So if you're using porting to GTK, you can just keep using the Lipcurl implementation. It's going to probably work on all Linux platforms. And if you don't have a main loop or a thread IPC, we have this implemented for you already, this libuv. I don't know if you have heard about libuv. It's the main loop implementation that Node.js is using. In fact, I look it up because I've been calling this libuv lib ultraviolet for a while, because I don't know, UV, but in fact it stands for Unicorn Velociraptor, which is a very interesting name. So we wrote the point of I will talk more if I have more time about the details of porting this to a new platform, but I'm a bit short on time. So we wrote a blog post about describing the details. And again, we are doing the development in the open. So we have, I'm usually hanging out on Slack channels, IRC channels, especially on the Qt mobility IRC at Freenode. So I invite everyone to help us. I would, especially the GTK guys, if there is anyone here doing GTK, to join us. So thank you, and if you have any questions.
Thank you for the presentation.
Please.
So full disclosure, I'm one of the maintainers of Node Maps. So about porting, when you ported to Qt, was it a port of the Mapbox GL Native module, or was it a rewrite to fit into Qt? Was it a linking toward? Did you link with the Mapbox GL, or did you rewrite it to Qt?
Yeah. So when we port this to Qt, was the core of the engine is 100% C++, like portable. We didn't have to change that. We rewrote the platform adaptations to work with a Qt main loop and the Qt network stack. And now Qt is going to ship our engine inside the Qt SDK. So it's there. So we are making release for Qt. And if you download the Qt SDK 5.9, you're going to get this engine included for free.
If I want to deploy the native renderer somewhere, should I have a big CPU or GPU or a fast hard drive?
Okay, so the question, sorry I forgot to repeat the other one, but is about the platform requirements.
Please repeat the question.
Yeah, so the question was about platform requirements. The cheapest hardware I managed to get this running with decent performance was the latest Raspberry Pi, the board.
If I have a
So-
server, like, is it good to have a GPU?
Yeah, you need a GPU. Yeah, you need a GPU, but you can also, if you want to rasterize things using our engine server side, is also possible. You can use this Mesa software rasterizer, but it's going to be a bit slow, but it works. We do that because we have you do for running unit tests and stuff like that. We know it works. Any more questions? Okay, if not, thank you for your time, and I will be hanging out here if you have any more questions. Thank you.
Do you have the cable for that to save my life just a little bit? Because I'm 80% and can I tell you why 15 minutes? Great, because after we have to go playing.
No, but
see?
it's no problem. I can pick
In fact, it's in my bag and it's 20 minutes I'm looking for in my bag. And I don't know.
I need it now.
It's perfect, you save my life. Or else I pull out my pajamas from my bag.
No, it's okay.
Perfect. And it's so clear, nothing inside, no scanning, nothing dangerous. Oh, stickers.
I scan
I take
everything
one
and I
minute.
collect everything in.
I'm putting more on there.
Little by little. Thank you.
Joanna?
Oh, I'm safe. Where was that cable? Why they don't use IoT to detect the cable in the bag?
I will make a break after the presentation starts.
Oh,
Then I
it's
come
okay.
back. And then we were planning with Madi to leave around 4. So before the presentation at 4.
Okay, that's good.
Because of
I will